Practical 2 is preparing a standard solution and for titration. So what is the aim here? What is the objective? Objective is prepare a standard solution. Standard solution means a solution with the known concentration. So if I know the solution concentration, I'll call that as a standard solution. So example, if you want to prepare a standard solution from a solid acid salt to find the concentration of a sodium hydroxide by using a titration. So first what we do, we weigh out the mass of acid salt and transfer. Like example, there's a acid salt which is, or acid is there, which is reacting with sodium hydroxide. So first what we do, we measure the mass of the acid salt and transfer into a clean beaker. So there is a beaker and we add a known mass, like example 2 gram, 3 gram, but a known mass of acid salt is there. Then add about 50 cm cube of distilled water or deionized water. So we add water here. We add water and stir. So when we add water and stir, the salt will dissolve. So it will disappear or it will dissolve. Then using a funnel, transfer to a graduated volumetric flask. So in a volumetric flask is having the advantage of volumetric flask is it's having only one label. Like either it will be 250 cm cube or 125 cm cube, but there is only one label. So there is 125 cm cube label is there. What we did, we make a solution, like we dissolve this solid into the distilled water and then we add to a distilled water. But when we add to distilled water, it won't, or it is an example 250 cm cube this volumetric flask is there with a maximum volume of 250 cm cube. So when we add, this was only 50 cm cube, so it will not cover up all, it will be here. Then what we do, we transfer the washing. Like we transfer the washing means like add more distilled water to the flask, to this beaker, and then transfer to the volumetric flask. And then we add the distilled water until it will reach the mark of 250 cm cube. So now we know the mass and we know the volume, because mass is the one which we add, and we know the volume. Mass divided by volume, what we'll get the concentration of this solution. And shake this volumetric flask until we have like uniform mixing of the solute with the solvent. This is how we make a standard solution, a solution with a known concentration. But what could be the errors? What might be the errors when we are doing this experiment? Number one, then this solution can be used for titration. That's a secondary part. But how to make a standard solution is we take a solid, we add water, we stir, make dissolve, and then transfer to a volumetric flask, then wash the beaker and transfer the washing into the volumetric flask and fill up the volumetric flask up to the mark and place a stopper and make it upside down or shake so that it will have a uniform concentration. What might be the errors? Be careful not to lose any solid, because if some of the solid might be lost or some of the solid might be left in the beaker, then it won't be accurate. When weighing out the solid, weigh by difference, like calculate the mass of solid in a beaker. So like mass of weighing bottle and a beaker, and then mass of a bottle after it is emptied with a solid, so will give a more accurate result. And journal titration procedure described, like in that is core practical 3 will discuss how it is titrated. What are the key point? Acid must have a high molar mass, because if it's having a high molar mass, it will reduce the percentage error. A sample must be pure, and a sample must be air sensitive, not be air sensitive, because it might react with air or absorb water or carbon dioxide from the atmosphere. So these are the key points which we should keep in mind when we are preparing a standard solution for titration. Practical 3 is how we use this solution for titration, but practical 2 is how to make a standard solution.